Okay, so today we're actually continuing with 6.4. We started 6.4 last time. That was the addition and subtraction of the rational expressions. We went ahead and separated the simplifying the complex because these can be a little bit tricky. I thought that was a bit much to try to do in one day. Okay, so a complex rational expression. It's the same thing as a complex fraction. A complex fraction is when you've got a fraction within a fraction, right? So either your numerator has a fraction in it, or your denominator has a fraction in it, or both of them have fractions in it. So these first three are all examples of complex expressions. The first one is just a complex fraction. You'll notice in each of these, you have kind of a darkened, heavier fraction bar and then a lighter one, okay? So always pay attention to where that dark one is located because that's the one that tells you, where the smaller fractions are. So in the first one, it's just 7 over 2 plus 1/2, right? And so again, seeing that this dark fraction bar is here, it's this 7 all divided by this 2 plus 1/2. The next one is 5 plus 1y, 1 over y, all over 5 minus 1 over y. And again, we see that we have this dark, heavier bar here. So it's that, basically a binomial divided by this one. And then the third one again, we have x plus 4 plus 1 over x plus 2. So again, we have this divided by, and we can tell by where that heavy fraction bar is, all over x minus 2 plus 1 over x plus 2. Okay. So again, these are all examples of complex rationals. Okay, so when we talk about simplifying them, it's because we never leave a fraction in a fraction, right? If you have 1 over 1/4, are you going to leave it as 1 over 1/4? No, you're going to simplify it down to just where you have a single numerator and a single denominator. All right, so we're going to go through two methods today. So this is the first method here, where you basically rewrite the numerator and the denominator of the complex fraction as single fractions, and then you divide them, just like we did when we first started this unit. So just a very basic example of this one. We have a over b all divided by c over d. And again, we can tell it's a over b because we have the heavier fraction bar here. So we know that a over b goes together, all divided by c over d. Okay? And so just like we did before, we'd say, okay, well, this is the same thing as doing a over b divided by c over d. And then from there, we would take that a over b and then multiply it by the reciprocal. And in the end, we end up with AD over BC. So that's what we're going to be doing with method 1. So here's our first example. I have 1 plus 4 over a, all divided by a over 6 plus 2 over 3. And again, I know that it's this divided by this because of where that heavy fraction bar is located. All right, so using method 1, that means I'm going to take my numerator here, which is 1 plus 4 over a, and I'm going to divide it by a over 6 plus 2 over 3. And why is it important that I have those parentheses around? Single term. If I don't have the parentheses, order of operations would tell us to do what first? Divide what?
4 over A.
4 over A divided by A over 6. Okay, so the parentheses are definitely very important here. Okay, so right now what I need to do is to create a single fraction both here and over here. So in the first one, I have a common denominator of what? And just this first one over here. What would my common denominator have to be? A. All right, so that means I'm going to multiply this 1 by A over A. And so that's going to give me A plus 4 over A. And then we'll divide that by. And looking at the term over, I have A over 6 plus 2 over 3. What's my common denominator there? 6. Okay. The A over 6 is fine, but the second term I'm going to have to multiply by what? 2. It'll be 2 over 2. Okay, and so that's going to give me 4 in the numerator and 6 in the denominator. And so I end up with A plus 4 all over 6. All right. So now that I've got a fraction divided by a fraction, I'll do just like we did before. Keep the first term, change this division to multiplication, and flip the second term. So this becomes 6 over A plus 4. And then what nice thing happens? Yes, the A plus 4s are going to divide out. That's gone, that's gone. And in the end, we simplified down to 6 over A. And then I also need to pay attention to any restrictions. What do we know A cannot be? Negative 4. Okay. There's our first one. All right. Any questions on what we've done? So let's look at the next one. All right. So again, I know that it is 6 over x minus 2, all divided by the 1 over x minus 2 plus 3 over x. Again, I can tell by where the heavy fraction bar is located. And so using method 1, again, I've got 6 over x minus 2, all divided by 1 over x minus 2 plus 3 over x. So our first term is already in a single numerator and denominator, so that's going to stay the same. The second term, however, needs a common denominator. So what's our common denominator going to be there? Okay, and are we going to distribute that through? No, don't distribute the terms. Go ahead and keep them separate. Okay, so least common denominator is x times x minus 2. Okay, so in the first term here, I have 1 over x minus 2. I am missing the x only, so I'll multiply the numerator and the denominator by x. And the second term, I have the x already. I'm missing x minus 2, so I will multiply the numerator and the denominator by x minus 2. So now I'll have the common denominator. I have 1 times x over here, so that'll be x. And then once I distribute this through, that'll be plus 3x minus 6. And all of it is over x times x minus 2. Okay, so now I have just a single fraction. Oh, what did I do here? I haven't flipped them over yet, have I? I should still have a division sign here. There we go. Okay, so now I need to combine like terms, but I also need to flip that second term, so I'm going to do that in one step here. 6 over x minus 2, change the division to multiplication. Now I'll have x times x minus 2 in the numerator, all over. Once I collect my like terms, I have 4x minus 6. Okay. And then what do we notice happens?
X minus 2.
X minus 2's. We can divide those out, and I'm left over with 6 times x in the numerator and 4x minus 6 in the denominator. But is there something further I can do to simplify? Okay, my denominator is factorable by 2, so I factor the 2 out. That leaves me with 2x minus 3, which now means I can divide my 2 into the 6, and I get 3, and in the end I have 3x over 2x minus 3. And are there any restrictions on x? Yes. X cannot be 2. Anything else?
0.
Also cannot be 0. And again, that comes from the original because we had that x in the denominator up there. Okay. All right. Any questions on what we did here? Yes.
Oh, when you flip this the second term, why did it become 4x minus 6?
Oh, because I combine these terms here.
Oh.
X plus 3x. Okay. All right. I have a couple for you guys to do. Move this over a little. And then we'll come around and answer questions. Okay, so what did you end up with for C? B minus A over B plus A. Any restrictions? Yeah, A can't be 0 and also B cannot be 0. Okay. How did C go for everybody? C was okay. All right. How about D? What did you get for D? X minus 5. All over x minus 2. Yes. Okay. Any restrictions?
X cannot equal 3.
Negative 3. Beautiful.
How do you do D words? No problem, Mia. You do no problem. I'm so glad I read you that. My entire purpose is to serve you. So that's x squared. Wait, where did the negative 2 come from?
For the x minus 5 over x minus 2.
Let's see. So, in order to get a common denominator up here, we would have to multiply this one by x minus 2 over x minus 2. So then that would give us an x squared minus 2x minus 15 all over x minus 2, and then divided by x plus 1, or sorry, x plus 3 over 1, so that would become times 1 over x plus 3.
Thank you.
Okay. All right. And then factor. Okay. Okay, any other questions from those? All right. So now we are going to look at method 2. So method 2 is my favorite method. I just find everything cleans up much quicker, but you have to be really careful. Okay. So what changes in method 2 is, again, I've got A over B, all of it being divided by C over D. Right, so again, it's all of this divided by all of this. So what you do in method 2 is you look at the denominators in the whole thing, okay? And you find the least common multiple of all the denominators. So again, if I look at just the top piece here, I see that I have a B. And if I look at the bottom piece here, I have a D. And so that means that my least common multiple here is B times D. And so what you do is you multiply the entire term, both the numerator and the denominator, by BD, the least common for the whole thing. All right. So I'm going to break that down over here. We already see what it simplifies to, but breaking down, what happens is if I have A over B times B over D. Remember, BD is like having over 1. What happens when you multiply those two terms? The B cancels. And that's why we're left with just AD. Okay. And same thing in the denominator. If I have C over D and I'm multiplying it by BD, what happens in this one? The D's are going to cancel, and we're left over with just CB. Okay. So again, this cleans up really fast, but you've got to be careful with the terms. And when you're first learning these, if you start mixing up the two methods together, you can create quite a mess, which becomes hard to follow. Okay, so let's run through. Anybody recognize A?
It's the same as the first one.
It's the exact same one that we did the first time using method 1, but this time we're going to use method 2. Okay, so again, in method 2, what we do is find the least common multiple of all the denominators. So if I look at my main numerator here, what do I have in my denominator there?
1 and A.
Okay, 1 and A. So that means I'll have an A. And now I look at the denominator here. I have 6 and 3. So what's the least common between there? 6. So 6A is going to be the least common multiple of all the denominators. So that means I'm going to multiply all of this by 6A and all of this by 6A. All right, so being very careful to distribute this correctly. I now have 6A times 1, which is
6A.
6A. Now for the next one, okay, I'm going to write it on the side here. I have 4 over A times 6A. What happens here? The A's will divide out, and I'm left over with 24. Okay, there we go. Now, my denominator, again, I'm going to multiply A over 6 times 6A, and I'm going to write it on the side again. A over 6 times 6A. What happens in this one?
6 is
Well, do the A's cancel? No, they're both in the numerator, so now I'm left over with A squared. Okay, and for the last one, I have 2 over 3 times 6A. What happens here? The 3 divides into that 6, leaving 2, and what am I left over with? 4A. Okay. So, do you see how nice that works out? I got rid of all the fractions within the fractions, and now I just have a numerator and denominator, and I just need to see if I can clean it up any further. Is there anything I can factor out of the numerator?
6.
6, which leaves me with a plus 4. And from my denominator, a, which leaves me with a plus 4, which now means I have a common term in both the numerator and the denominator that will divide out, and I'm left over with 6 over a. I know a can't be 0, but I have divided out the other term, which is negative 4. Did we get the same answer?
Yes.
Yes. Okay. Which method did you think was easier? Second. Yeah. So usually the second one is quicker, but again, you have to be careful. If you don't distribute your terms properly, again, you can make quite a mess. Yes.
When we do quiz and tests, do we get to choose or are you to say do?
Most of the time it's choose.
Okay.
Yeah. Okay. Let's look at this one. I have 2 plus 1 over x, all divided by 4 minus 1 over x squared. And again, I know that it's this term here divided by this term based upon where that heavier fraction bar is. So again, I'm looking at the whole thing. If I look at my big numerator first, what do I have in the denominator there? An x. And if I look at the denominator, what denominator do I have there? X squared, which means what is the least common multiple of x squared? Okay. All right. So since it's x squared, I'm going to multiply both the numerator by x squared and the denominator by x squared. And again, it's a matter about being really careful when you start distributing. So now I have 2 times x squared, which is 2x squared. And what happens on that next term? I now have x squared times 1 over x. What happens? One of the x's will cancel, and I'm left with a single x. All over. Down here, I have 4 times x squared, so that's 4x squared. And when I multiply 1 over x squared by x squared, I just have 1. It's a minus 1. Okay. Fractions are gone. Now I need to see if I can clean this up. Is there anything I can factor out of the numerator? X. That leaves me with 2x plus 1 here. And is there anything about the denominator?
No.
Sure.
Is it a perfect square?
It's the difference of 2 perfect squares. Okay, so the difference of 2 perfect squares, what's that going to factor into?
2x minus 1.
Here we go. 2x minus 1, 2x plus 1. And isn't that beautiful? Now I have a common term here and here, which I can divide out. I'm left with x over 2x minus 1. Any restrictions on x?
X does not equal negative 1/2.
Cannot equal negative 1/2. And is there anything else? 0. That comes back from the original problem where we had a single x in the denominators. Okay. Any questions on what we did there? Yes, Lola.
Why did you do x squared by both?
In the numerator and denominator?
Yeah.
Okay, because we had a single x in this denominator here and an x square. So that means the least common has to be the higher degree. Yeah.
So why wouldn't you just multiply the top one by x?
No, you have to multiply by the least common. Because, so remember this over here is x squared over x squared. That's just equal to 1.
Okay.
So you can't use a different term to multiply to the numerator and a different one from the denominator. It has to be the exact same. Okay. So here are a couple for you guys to try. Move this one over some. Okay, so it sounds like most of you guys are finished. What did we end up with in C? 2/5, and yes, there's no x's left, but from the beginning we know it can't be -2. Okay. Oh wait, I do think that in the simplification process, yes, you ended up with an x and x, right? So yes, it also cannot be 0. You are correct about that one. Okay.
Oh my gosh, wait, I just realized something. No, it's 2
And
over
D
5
is,
minus
yes,
4 over 10, which is like
x plus
that's like
3
2,
over
like
2. And any restrictions on x?
X cannot be equal to 3.
Wait.
Just 3?
Or negative.
Or -3.
Yeah.
Yes, 3 or -3.
I was like so confident.
Okay.
Yeah.
So what did you guys think about method 2?
I like it.
I like it.
Except for
Yes.
Yeah.
Yeah, and method 2 is usually faster. That's definitely my preferred method, but again, you have to be careful. Well, you really have to be careful with both of them. There's room for error in both. Okay, so here are 3 more for you guys to work through. You can use the method of your choice. Let me move this one over here. Oh, sorry, I got one more down here. Let me move it.
Actually, I feel like the one we just did, mostly because I forgot something in the first class. But I feel like this one is easier.
Okay, can you guys,
Thank you.
let me move that a little bit so I can move back up. Okay, so method of your choice, and I will go around and answer questions. And again, number 25 is up on the board. Okay, here are the last 3 examples worked through using method 2. So there's the work for A. And there is B. And the last one, C. Took up a little more space, so there's the beginning of the work. And in the end, you end up with 2 trinomials that you have to factor. And there's the final answer.